Now let us see how to get the block diagram and signal flow graph from electrical system. For a simple case, we'll take RC system. R and C are connected in series. Vi is input and V0 is the output. Now first we'll see what is the signal flow graph. To get the signal flow graph, we write some equations of the network. We start from the output end, right? So output is V0. I am taking at the capacitor node V2. Therefore, I can write V0 is equal to V2. This may be the equation number 1. But what is V2? It is the voltage across the capacitor. The capacitor, we write it as 1 by Cs, and current through the capacitor is I. I can write the equation V2 is I into 1 by Cs. This is equation number 2. Now, I want to write the equation for the branch current. The branch current I is Vi minus V2 by R, or we can write as a Vi by R minus V2 by R. This is equation 3. So when you combine these three equations, then we can get the signal flow graph as it is given. So input node is Vi, followed by the node I, the next node is V2, next node is V0. And we have only one feedback, that is from Vt to I, and we have all the gains. From Vi to I have 1 by R, I to V2 we have 1 by Cs, and Vt to I have minus 1 by R. Similarly from Vt to V0 I have 1. I can apply the signal flow graph formula, that is Mason's gain formula. Then I can get the transfer function very easily. V0 by Vi is 1 by 1 plus RCS. Now the block diagram. We have three equations available, equation 1, equation 2, equation 3. Let us take the equation 3 and we draw the block diagram. So in equation 3 there are three things, Vi, V0 and I. So using the equation I can draw the block diagram as shown here. I have input Vi and there is a block 1 by R, and after that we can take the summing point. And there is a feedback which is coming from V0, that is 1 by R, which is a negative feedback, and output is I. So that equation 3 we can represent here like this. Similarly equation 2 and equation 1 also we can represent as, so I is input and V2 is output. The block transfer function is 1 by Cs. Similarly from V0 to V2 we have a gain 1. So when you combine all three blocks, then we will get the complete block diagram of the electrical system, which is given here. Now if you look at here, Vi and I have black 1 by R and summing point, and there is a feedback. In this feedback we have 1 by Cs is a forward path, 1 by R is a feedback, this is a negative feedback. Then you can simply reduce this and we can get the transfer function as V0 by Vi as 1 by 1 plus RCS.